Salam everybody, welcome to Physics with Nosher, and let's discuss the first question. Alright, so the principle of conservation of momentum, the total momentum before collision must be equal to total momentum after the collision for an isolated system. What do we mean by an isolated system? That there should be no external force besides the forces between the two objects when they collide. So when two good things collide, they're always obeying Newton's third law, and that means there's a force on object A and there's a force on object B, but there should be no third force. That is what we mean by an isolated system. Describe the difference between elastic and inelastic collision. Kinetic energy is not conserved in inelastic collisions. Now, an object of mass 4.2 kg and horizontal velocity 3.6 moves towards object B as shown. The mass and the speed are given. I've assumed this direction to be positive and this direction to be negative. The objects collide and then they move off in the same direction. A moves to this side, B moves to this side, and object A has a velocity v and object B has a velocity of 3 meters per second as shown in the question. So this is 3 and this is v. We need to find. I've already found the answer. It would be 2.1, but we still need to find this. So if you apply the law of conservation of momentum over here, let me just do it right here. And let's find v. m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Now, firstly, these two are moving in opposite directions, right? And I've taken the right direction to be positive. So 4.2 into 3.6, this is positive, minus 1.5 into 1.2, because 1.5 is the mass of object B, is equals to. Now, when you go to the other side, both are moving right. So 4.2 into V plus 1.5 into 3, because this has speed 3 and this is mass 1.5. So 4.2 into 3.6 minus this should be equal to this plus this. Let's go and find out. And here we go. So 4.2 into 3.6 plus this thing, we put the minus sign over here. 4.2 into V plus 1.5 into 3. The velocity turns out to be 2.1 meters per second, 2 to 3 significant figures. Now you have to explain whether the collision is inelastic or elastic. So a test is relative speed of approach should be equal to relative speed of separation. If this turns out to be true, then the collision is elastic, and if it doesn't, then it's inelastic. But remember this, that for this equation to hold, all particles have to be moving right. Like when this equation was derived, we were assuming all particles are moving to the right. Bear that in mind. Now you had two particles in the beginning of this question. One was particle A and the other was particle B before they were moving in opposite directions. Remember? And particle A was moving with a speed of 3.6 meters per second and particle B was moving with a speed of 1.2 meters per second, if you remember. This was before. And after the collision happened, both particles were moving right. Particle A, we found the speed to be 2.1 meter per second. And for particle B, I think the speed was 3 meters per second. This was after. So, and this was before. So when you're applying this equation over here, you need to understand that u1 minus u2 comes when both particles are moving right. Right now, one particle is moving left. So instead of doing u1 minus u2, you'll have to do u1 plus u2. And when you'll do u1 plus u2, you will end up getting 3.6 plus 1.2. So 3.6 plus 1.2 on the left-hand side is equals to v2 and v1 were both moving to the right and they're also moving to the right. So this is v2, this is v1, and we will subtract 3.0 from 2.1. So 3.6 plus 1.2 gives you 4.8, and 4.8 does not equal 0.9, and that is exactly what we got here, and that is why we said that this collision is inelastic, because the two sides do not turn out to be equal. Alright, let's have a look at question number 2. The speed is defined as distance traveled per unit time or rate of change of distance. It's scalar, and velocity is rate of change of displacement. That's vector. Now you have a ball which is released and it rebounds. The graph will show you that it goes down And just before hitting the ground, the time that has elapsed is 1.1 second. Then it rebounds upwards. So let me walk you through this. When your ball falls down, the speed increases all the way to this point. Your maximum speed is 10.8 meters per second just before hitting the ground, and the time is 1.1 seconds. Then, when it comes in contact with the ground, the speed decreases to 0, and then because the ball has to now move back up. So when the ball hits the ground, after hitting the ground, it has to go back up, right? It releases itself from the ground at 1.2 seconds. So this is the time when it's going up, and the time over here is 1.2 seconds, and it goes up with a speed of 8.8 meters per second. Negative sign shows the direction is opposite. And why is the speed less? As in, when it goes back up, its speed is 8.8 meters per second, but when it was coming down, just before hitting the ground, its speed was 10.8 meters per second. Maybe it lost some energy on collision. The collision is inelastic. So it starts from 8.8 meters per second and starts to go up, up, and up. And then at this point, it stops. This is the highest point where you have reached. And then again, it turns down. And that is why the speed begins increasing again. This part shows that it's coming down again. Now, if I ask you how much distance have I traveled from here to here, then you'll have to calculate this area under the graph, because this area represents the distance traveled when going down. So area of the triangle from t is equal to 0 to t is equal to 1.1. Half into base into height, half into 1.1 into 10.8. That gives me 5.94 meters. So 5.94 meters is the distance that I've traveled when going down. Now, how much distance did I travel when going up? So that started at 1.2 seconds, that journey. And when did that journey end? That journey ended at 2.1 seconds. When did that journey end? Let me zoom in. Here you go. This point is 2 and this point is 2.1. So that journey ended. You reached your highest point at 2.1 seconds. So if I show you in this picture over here, when you reach this point, 2.1 seconds is the time. And when you left the ground, it was 1.2 seconds. So let me fit this in. Yes. So 2.1 is when you're here and 1.2 seconds is when you're here. So again, when I calculate the area of this triangle, it's half into base into height. Base is this length, which is 0.9, 2.1 minus 1.2, and the height is 8.8 meters. So you get 3.96 meters on the way back. Now the question is, if they ask you what is the total distance that you've traveled, so to calculate the total distance traveled, you have to calculate literally all of this. So 5.94 plus 3.96, the total distance will be 9.9 meters. However, if they ask you what is your displacement, always remember it's from the start point till the end point. So you started from here, you went down, you came back up. This is your end point. This is your displacement. So for displacement, you will have to subtract these two. So 5.94 and 3.96 you will subtract and you get 1.98. A lot of kids ask me this question, that why did I ignore the negative sign during distance? Distance is scalar. So distance is literally the total length that you move. Displacement is vector. So you can see I took 5.94 as positive and 3.96 as negative, added it, and I got 1.98 because their directions were opposite. That's why one is positive, the other is negative. The other way of looking at it is I'm talking of displacement. So I'm looking for this distance. When this is 5.94, this is 3.96. So what would this distance be? Just subtract them. And this is your displacement. And if they ask you what is the direction is downward from start point till the end point. They could also ask you to calculate the acceleration of the ball when it goes back up after rebounding. So for that, I've taken the coordinates of this point. The time was 1.2 seconds. The speed was minus 8.8. So I've written 1.2 comma minus 8.8. And I've taken this point. You know that at this point, the speed was 0 and the time was 2.1. So 2.1 and 0. Just use these two coordinates, y2 minus y1 over x2 minus x1. And that is how you can get the acceleration. You could even use this point. So at this point, Your speed is 8.8 meters per second. And what is the time? Your time is 3 seconds. So you could even use, if I write down the coordinates for you, you could even use 3.0 comma 8.8 with this or with this. Because it's a straight line, no matter which 2 points you take, the gradient will be constant and the gradient will give you the acceleration on the way up. So that is how you calculate the acceleration. The first part says, without calculation, you have to explain how the velocity is varying between 0 and 2.1 seconds. So you can clearly see that your velocity is increasing at a steady rate, and then at 1.1 second you hit the ground, then you rebound at 1.2 seconds, and you travel up until you hit maximum height at 2.1 seconds. So let's have a look at the answer. So velocity increases uniformly from t is equal to 0 to t is equal to 1.1. At 1.1 you hit the ground and rebound with a velocity of minus 8.8. Then you uniformly decelerate to 0 meters per second at 2.1 seconds. You can also say that the speed decreases constantly to 0 meters per second at 2.1 seconds. What is the acceleration of the ball after it rebounds? I already told you this. The answer is 9.8 meters per second square. Then the distance moved, already calculated that value, above 9.9, and the displacement 1.98. Now they're asking you to sketch the variation of the speed of the ball. Let me go back to the original graph. Guys, please remember, what is the difference between speed and velocity? Velocity is vector, speed is scalar. So all we have to do is we have to remove this negative and reflect it into the positive part. So basically this peak of minus 8.8 will come here at plus 8.8 at the same time of 1.2. So the graph will go this way, then it'll go down to this point over here, not the orange line, the white line. Then it'll go back up to 8.8 at 1.2 because this line represents 1.2. And I'm basically reflecting this point over here because speed cannot be negative. And then when I reach this point, then I have to join it at 2.1 for the speed to be 0, straight line down, and this is the graph. So let me show this to you. This is what the graph looks like. Let me zoom in. So if you notice, this part is the same. Then you had a straight line down all the way till 1.15. And then at 1.2 seconds, your speed should be 8.8. And then when you're going up, your speed decreases because you're decelerating all the way to 0 at 2.1. And then again, you're coming down, so your speed increases to 8.8 at 3 seconds. That is the graph. Next part, make estimates. What is the mass of a meter rule? 150 grams, 200 grams, 100 grams. Volume in cm cube of cricket ball or a tennis ball, 100 cm cube. Just memorize these. Part B, metal wire of length has cross-sectional area this. Now you have to calculate the density of the metal and the percentage, not the percentage, the absolute error in the density. So let's start this question. Now, the first thing I want you to focus on is how do we get the value of density? Let me walk you through. So first, I find out the volume of the wire by using pi d square L by 4 over here. So pi, diameter is 0.38 millimeters converted to meters. 10 to minus 3 whole square into L, 25 centimeters converted to meters, divided by 4, I get the volume. Then I calculate the density. Density is mass over volume. Mass is 0.225 grams converted to kg, so 10 to minus 3, divided by volume, and I get this as my density. Done. Now I need to calculate the percentage uncertainty before I get to the absolute uncertainty. So percentage uncertainty in density is equals to percentage uncertainty in mass plus the percentage uncertainty in the volume. Now, how do I get the percent uncertainty in mass? Percentage m is equals to error over value into 100%. So you get 0.44%. Now let's calculate the percentage error in the volume. To calculate the percentage error in the volume, you first ignore the constants pi and 4. Then you write 2 percentage d because it's d squared, so d came twice. 2 percentage d plus percentage L. Now, how do we calculate percentage D? Percentage D is calculated by doing 0.01 over 0.38 into 100%, which gives you 2.63%. And then how do you calculate percentage L? Percentage L is simple. You divide 0.1 by 25 into 100, you get 0.4%. So how do you get percentage error in the volume? You get percentage in the volume as 2 percentage D. Percentage D was 2.63. So 2 into 2.63 plus percentage L, which was 0.4. So 0.4. Add percentage uncertainty in the volume is 5.66%. Percentage M you already had at 0.44%. Percentage uncertainty in the volume is 5.66%. Add them, the percentage error is 6.1%. Now, ये 6.1% एरर किसके अंदर है? ये डेंसिटी के अंदर है. So you take 6.1% of the value of density to calculate the absolute uncertainty. Turns out to be 484. You round off to 1 SF. Errors are supposed to be given to 1 SF. So 484 turns out to be 500. And then because there's no decimal place here, so I don't need any decimal place over here, I can round off my answer to two significant figures over here. So I could write 7900. I could even write 7940. Both answers would be correct. This value cannot be more than 2 to 3 SF. What is meant by longitudinal with reference to direction of propagation of energy? You know, if this is the direction of propagation of energy, in a longitudinal wave, the oscillations or vibrations are parallel. And in transverse, if this is the direction of energy, then the oscillations should be perpendicular to the direction of propagation of energy. Part B. Now, intensity is given by this expression. You have to show that both sides have the same equation. Intensity is power over area. So power has these base units. Area is meter square. Speed, meter per second. I ignored K because in the question, they've clearly mentioned K is a constant with no unit. So you can completely ignore K in the equation. And density is kilogram per meter cube. Your frequency is given by S minus 1. So if it's frequency square, it'll be S minus 2. Area, sorry, this is amplitude. So amplitude is meter square. Now you simplify. M square will get cancelled. M square, M and M cube, they will get cancelled. So on the left hand side and the right hand side, you'll be left with kg S minus 3. And that shows that both sides have the same units. Doppler effect is the change in the observed frequency due to relative motion between the source and the observer. A distant star is moving away. When you're moving away, that's redshift. And if you're moving towards, that is blue shift. So what do you observe? You observe an increase in the wavelength when you're moving away. Now, they're saying a car travels at a constant speed towards a stationary observer. The horn of the car is emitting a frequency of 510 hertz. But when the observer hears, this is the observer, observes 550 hertz. What is the speed of the car? You're moving towards. So the formula that you have to use is F dash is equals to V over V minus US into F. When you're moving towards, the frequency should be more. Therefore, denominator में minus का sign आता है. If you were moving away, तो यहाँ plus sign आ जाता है. This V is the speed of sound, and this is the speed of the source which you want to find. So basically, you're trying to find US. So F dash, which is 550, should be equal to V, which is 340, divided by V, 340, minus US into 510. 510 was the actual frequency. And when you simplify, you get 24.7 meters per second. All right, let's have a look at question number 5. You're given these heaters. This is the power rating. This is the voltage. The first question says, what is the resistance of one of the heating elements? So you use P is equals to V square over R, and you get your resistance as 38.4 ohms. Now let's discuss part B. I'm going to solve each part one by one and show you the circuit for each part. So the first line is number 1. Switch 1 is open, switch 2 is closed, switch 3 is closed. Let's go. So when you look at number 1, let me zoom in. Switch 1 is open, switch 2 is closed, switch 3 is closed. Is there any way that the current can flow anywhere? Please tell. Is there any way at all that the current can flow from that? Let's say this is the positive terminal, the current can't get out. This is the positive terminal. The current can't get out because the current cannot find the negative terminal. Please remember this. If you say that this is positive and the current can go here and here and here, and then it realizes, oh no, the switch is open so I can turn back. No, that is not possible. If the circuit is broken, current cannot flow in any case. So that is why there is no power dissipated by the heater. And we'll say that the power is 0 watts when switch 1 is open, switch S2 and switch S3 are closed. Now in the second scenario, switch 1 is closed, switch 2 is closed, and switch 3 is open. So the first thing you need to identify is how is the current flowing. Before I go to that, you need to understand that if I have this circuit, for example, I have this resistance and I have this resistance, how many resistors are experiencing a current? 2 resistors are experiencing a current because the current flows like this. Make sense? Now guys, let's say for example, I attach a switch over here. All right. If the switch is open, the current still flows through the 2 resistors. But what will happen if the switch is closed? Guys, if the switch is closed, this will become a jump wire. A jump wire has 0 resistance. And remember this thing that I'm going to tell you now, that current always prefers a jump wire over a resistance. So current will always prefer a jump wire because current will always prefer a 0 resistance path. This does not apply to any other case. Don't tell me that, well, this can also work if, let's say, for example, I have this circuit and I have one resistance of 10 ohms and I have got one resistance of 1 ohm, and then the entire current should just go through 1 ohm because this is least resistive. No, it does not work on that. It only works if the resistance is 0. So if you tell me that this resistance is not 1, it's 0 ohms, and now I ask you what is the direction of current, you will say that the current will just flow through this because the current will always prefer the 0 resistance path, right? So if, let's say, we close the switch over here, then this is a 0 resistance wire. So how will the current flow? The current will start from here. There's no option. It has to start from the positive terminal. It will flow through this resistor. And then what's going to happen? The current is going to jump on this wire and go back to the negative. So this resistor is skipped. There will be no current in this resistance. So this resistance will not be counted now. Does that make sense? So remember that whenever you jump a resistor, that resistance is not counted because the current did not pass through it. So if you apply the same logic over here, let's say this is the positive terminal. The current starts, reaches this point. It passes through A, cannot go down because this switch is open. So no current can go here. So passes through A. And now it reaches this point. Now you guys tell me this switch is closed. So this is your 0 resistance path. So what will the current do? Will the current pass through heater B or will it go down and back? The answer is it will go through the 0 resistance path. And when it reaches this point, please never be confused कि current नीचे तो नहीं चला जाएगा. क्यों जाएगा नीचे? Current whenever exits the positive terminal, it's always looking for the negative terminal. So current will go back to the negative terminal like this. Don't even think that the current can go back towards the positive. That's very weird electricity concept, and it's absolutely wrong. So never ever think on those lines. Whenever current leaves the positive terminal, it is always looking for the negative terminal. So if the current is flowing like this, how many resistances have come in your way? Just one. Right? So the resistance of one heater was 38.4. We already calculated that. The power that you're supplying was 240. So power is 240 square over 38.4. And you get the power as 1500 watts. Because in the table, they're asking you to express in kilowatts. So you write 1.5 kilowatts. Let's go to circuit number 3. In circuit number 3, all switches are closed. So let's start. This is the positive terminal. So the current goes this way, reaches this point, splits, part of it goes here, part of it goes down. Does that make sense? That the total current that was coming splits into two parts, I1, I2. Part of the current goes down because the switch is closed and part of the current goes here. Now when I1 passes through A, reaches this point, it sees that 0 resistance path again. So what happens? it goes through here and up, and this current I2 flows down, passes through C, and goes back. So your current is essentially flowing through two resistors, A and C. Now A and C, are they in series or are they in parallel? They're in parallel. So how do you find the resistance in parallel? You do, if they're similar, you can just take the resistance of one resistor, because दोनों same value के हैं, तो 38.4 किसी एक resistor की value divided by the number of resistors. So 38.4 divided by 2, 19.2. If you don't like that method, no problem. Just do 1 over R total is equals to 1 over 38.4 plus 1 over 38.4, and find out the value of R total from here. The value of R total will be 38.4 divided by 2. Do it in your calculator. Do 1 over 38.4, do 1 over 38.4, add karo, but at the end, do not forget to take the reciprocal in your calculator. That the major problem with students is, वो ये लगा तो देते हैं, they remember how to apply this formula, but they forget to take the reciprocal at the end, because I'm not trying to find the value of 1 over R total. I want to find the value of R total. So R total will be 38.4 divided by 2, which is 19.2. Power, because you know they're in parallel, so voltage is the same. So 240 square over 19.2, I get 3000 watts, which is 3 kilowatts. Now in circuit number 4, they're saying S1 is closed. Guys, if S1 is closed, somebody could ask that why are we taking the left terminal to be positive? Why can't we take this? You can take any terminal to be positive. Let's take this to be negative. Let's see how the current flows. So the current flows this way, goes down. Can the current go further down? No. The switch is open. The current cannot go here either. So where will the current go? The current will go through B, and then the current will go through A, and then the current will go back, because I told you that when the current leaves the positive terminal, it's always looking for the negative terminal. So you've got two resistors in series. So what is the total resistance? 76.8. What is the voltage that you're supplying to both of them? 240. So power is 240 squared over 76.8. You get 750 watts, which is 0.75 kilowatts divided by 1000. And finally, the last case, switch S1 and S3 are closed, S2 is open. So how will the current flow? Let's again take this terminal to be positive. The current starts from here, goes down, passes through these two resistors. So let's say this is current I, this is I1, and at this point the current will split because current has to go over here as well. Let's say this is I2. I2 passes through C, and I1 passes through A and B. So what does that mean? That A and B are in series. So resistance of AB is going to be 38.4 plus 38.4, which is 76.8. Resistance of C is going to be 38.4. It's just a single resistor or a heater. Now, these two are in parallel with this. So apply the formula for parallel, which is R1 into R2 over R1 plus R2. I've considered both of them as one. So let me make it here. I'm considering A and B to be 76.8 ohms. I'm considering C to be this, which is 38.4 ohms. And they're in parallel, connected to a 240 volt supply. Like this. So what is the resistance in parallel? You could use 1 over R total is equals to 1 over R1 plus 1 over R2. But do not forget to take the reciprocal at the end. Or you could simply apply this formula, product over sum. You get 25.6 ohms. Now, power is V square over R. You were supplying 240 volts. So 240 square over 25.6 gives you 2250 watts, which is 2.25 kilowatts. An alpha particle is a helium nucleus with 2 protons and 2 neutrons. Alpha particle has a charge of plus 2e, and alpha's mass is 4u. A beta positive particle is a positron with a charge of plus e. That's one difference. It has a mass of the electron, which is 9.11 10 to the power minus 31. That's another difference. And it's a positron, so you can say it belongs to the lepton family. You can say alpha particle belongs to the hadron family. Next, state the equation that shows the decay of a particle in which beta positive emission is produced. So a proton, which is 1 breaks into a neutron, a positron, and with the positron, the particle that comes out is the neutrino. And if they ask you to explain this in terms of quark structure, remember this, you'll say up, up, down converts to up, down, down, plus the electron, plus the neutrino. They can even ask you like that. And if they ask you, how is the quark composition changing? You will say this up is converting to down. So on the up, you will write -1. On the down, you will say +1. That shows that 1 up has converted to 1 down. So there's a +1 and down. You can see 1 extra down, and you can see 1 less up. Quark composition already explained. Quark model up is +2 by 3e, down -1 by 3e. So you have 2 ups and 1 down. So the overall charge on a proton is +e. So interference fringes may be observed using a light emitting laser. So let's say this is your light emitting laser, and it's used to illuminate a double slit, and the double slit acts as 2 sources of light. So what is the part played by diffraction in the production of the fringes? You know that over here, if I have a screen, I'll have constructive and destructive interference pattern. So what is the part played by diffraction? The diffraction causes the waves to spread out. You can see that they spread out, and then when they spread out, they overlap, and then based on how they're overlapping, you have constructive and destructive interference. And the second part is, why do you have double slits rather than 2 sources of light? Because these 2 slits have the same source behind, so both of these slits will produce 2 coherent sources. If I have 2 separate sources, they may not be coherent, and if they're not coherent, then they will never interfere. All right, so when light passes through these 2 sources, I'll also show it to you here, the waves diffract, and when the waves diffract out, let me play it. When the waves diffract, what happens is you will see interference, and you will see this interference pattern that is being produced. So you will see a bright fringe, a dark fringe, a bright fringe, dark fringe, and that is exactly what they're asking you over here, that you see these 16 fringes. So you know that x is equal to lambda d over a, right? And what is x? X is your fringe separation. X is the distance between any 2 consecutive fringes. So this is a bright fringe, this is a dark fringe, this is a bright fringe. The distance between any 2 consecutive bright or any 2 consecutive dark is x. So first, I have to find out what is my fringe separation. I've got this length of 36 mm. I've got 16 of these fringes. So the distance between any 2 fringes would be 36 millimeters converted to meters divided by 16. That is going to be the value of x. And if you don't get that, that's fine. Just count with me. This distance is 1 fringe separation, 1x, 2, 3, 4, 5, 6. I'm talking about the gap. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 x's in 36 mm. So what is the value of 1x? What is the value of 1 fringe separation? 36 in 10 to the minus 3 divided by 16 is equals to lambda. The distance is 2.4, and the value of a, which is your slit separation, is 0.48 into 10 is per minus 3. I've already done the calculation for you, and the answer to the wavelength is 4.5 into 10 per minus 7. Now, whenever you get this sort of a question in which you have 2 dippers and they're meeting at a point and they're asking you what is happening, are they meeting constructively or destructively, you must memorize this test. That firstly, you have to figure out, are these 2 sources in phase or out phase? So the question says the phase difference between the waves produced at D1 and D2 is 0. That means they're in phase. They can also mention that the phase difference between the waves produced at D1 and D2 is 180. That means they are not in phase, they're 180 degree out of phase. For that, there's a separate test. But right now, they're in phase. So if they're in phase, the test is you find out what is the path difference to lambda ratio. Path difference is D2P minus D1P. Path difference is the difference in the distances traveled from the 2 sources to the point. So always the bigger distance minus the smaller distance. So D2P minus D1P, 11.2 minus 7.2, that will give you path difference, and the wavelength they've given to you in the question as 1.6. So if the path difference to lambda ratio turns out to be a whole number, then that means at point P they're meeting constructively. If they're meeting constructively, you'll have a lot of movement of water. If they're moving if the path difference to lambda ratio is a decimal number, that means it's going to be destructive interference. That means it's going to be no movement of water over there because the waves are meeting destructively. So let's find out. Path difference to lambda ratio, 11.2 minus 7.2 divided by 1.6 gives me 2.5. So it's destructive. Hence, there will be no movement at P. And remember, in your case, either you will get whole number or your decimals will be in 0.5. So it could be 0.5, 1.5, 2.5. If let's say it's 2.2 or 2.1, then it's partially constructive, partially destructive, but that's not in your syllabus. So they will never give you 0.2 and 0.3 and ask you to comment. They will always ask you to comment on destructive. Destructive means 0.5, 1.5, 2.5, any number with a 0.5, or you could get 1, 2, 3, which will be a whole number that will show constructive. And I've told you that if it's not 0.5, it's 0.6, anything besides 0.5, then that would be partially constructive or partially destructive. Now, see, I told you earlier that they could say that the phase difference between the waves at D1 and D2 is 180. Please remember this test. Then when they're 180 degree out of phase, then the same path difference lambda ratio, if it's a whole number, it's destructive, it's reversed. Because you're 180 degree out of phase, so that test is now reversed. If it's a whole number, it'll be destructive. It's a decimal, it'll be constructive. So they're asking, now what will you observe at P? Now, at P, I will observe maximum displacement because I already have the path difference to lambda ratio. That was 2.5. And 2.5 is a decimal number, but the two sources are out of phase. Hence, it's going to meet constructively the two waves. And then there will be maximum displacement at P. Another thing that they could do is, if they tell you that the amplitude of the wave from D1 is 2 centimeters, for example, and the amplitude of the wave from D2 is 3 centimeters, for example, and they ask you the same question to state and explain what is the effect, and you figured out that path difference to lambda ratio is 2.5, hence they're meeting constructively. Hence, at point P, when the waves meet, they will have maximum displacement. If they give you the amplitudes, you will even have to comment on the amplitude. The amplitude will be 2 plus 3, which is 5 centimeters if they're meeting constructively. And what if they were meeting destructively? What if path difference to lambda ratio was 2? If they're meeting destructively, then you will subtract and you will say it'll be minus 1 centimeter. And that still shows that there's destruction because it's less than the smallest amplitude. They're not meeting constructively, they're destroying each other basically. So state and explain the effect with 180 degrees. I've already told you this is the test. Now state and explain the effect if the intensity of wave from D1 is less than intensity from D2. So that means he's going back to the original question. The original question said that the two sources D1 and D2 are in phase. So what was the test for in phase? The test for in phase was path difference to lambda ratio. If it's a whole number, remember, please recall, it should be constructive. And if it is a decimal like 0.5 or 1.5, then it's destructive. And what answer did we get? We got 2.5. So that meant it was destructive. And now they're saying if the two sources have different intensities mean, you know, intensity is proportional to amplitude square. So that means that the intensity of D1 would be different from D2, meaning that amplitudes will be different. Now tell me something. If D1 and D2 are in phase and their amplitude is different and they meet destructively, so when they will overlap, will the resultant amplitude be 5 or will the resultant amplitude be minus 1? The answer will be the resultant amplitude will be minus 1. There will still be some movement at P since the amplitudes won't cancel out completely. Why are we saying that? We're saying that because if D1 and D2 had the same intensity, let's say for example, D1 and D2 had the same intensity. So D1 का भी amplitude 2 centimeter or D2 का भी amplitude 2 centimeter. And now they meet at point P and they meet at point P destructively. So will you add 2 and 2 or will you subtract? You will subtract. You'll get 0. So when you get 0 centimeter, I'll say there's no movement. But here, because the intensity of D1 and D2 are different, they will still meet destructively, but there will still be some movement. So some movement at P since amplitudes won't cancel out completely. For them to cancel out completely, the intensity of the two sources must be the same. So basically what we're trying to say is that if you want to observe these dark fringes, this one, this one, this one, let me just play it again for you. If you want to observe these dark fringes, you can see this is dark, this is dark, this is dark, then the two waves must have the same intensity. Here, what's happening is that if let's say this is D1 and this is D2, both have the same intensity. So D1, let's say, has an amplitude of 1 centimeter. D2 also has an amplitude of 1 centimeter, but it is in opposite direction. Hence, they cancel out. So do you see destruction? Let's say they ask you for this. Why do you see a bright fringe? Because if this is D1, 1 centimeter, this is D2, 1 centimeter, they get added. That is why you see the bright fringe. So remember that if you want to see complete darkness, the amplitudes have to be the same and they have to be 180 degree apart. If you want to see completely bright fringe, then both the amplitudes must be in the same direction. So coming back here, when paired difference to lambda ratio is a whole number and it's constructive, then D1 and D2 are both pointing in the same direction. But if paired difference to lambda ratio is a decimal number, which means it's destructive, so what happens is that D2 is not pointing in the upward direction. D2 is pointing in the downward direction. So D2 is pointing like that, and it's 3 centimeters if this is 2.5 and if D1 and D2 are in phase. So remember, whenever you say they're meeting destructively, you have a crest and you have a trough. Whenever you're saying that they meet constructively, you have a crest with a crest. So if a crest overlaps with a crest, remember you will meet constructively. If a crest overlaps with a trough, remember you will meet destructively. So if I want 2 minus 2 is equal to 0, should this direction be this or should it be reversed? The answer is it should be reversed. So I should flip it the other way around. I should make it like this. So this is 2 centimeters if they're supposed to meet destructively. And the last comment that I'm making is that when they meet destructively, if their amplitudes are equal, the resultant will be 0. There will be no movement. However, if their intensities are not the same, their amplitudes are not equal, when they meet destructively, there will be some displacement, there will be some movement.